This is the 4.1 Ready, Set, Go, and we're going to focus on the set and the go. So there are 11 problems, and before we start going over some examples, I wanted to talk to you about PEMDAS, or some teachers call it GEMDAS. Basically, it's an order of operations. So when you're looking at a problem that has multiple steps, you want to follow this order. So first you want to do parentheses or grouping symbols, which includes fraction bars. And then once you've gotten rid of those parentheses or those grouping symbols, then you can do exponents. And then you want to do multiplication from left to right, division from left to right, addition from left to right, and subtraction from left to right. So we're going to kind of use that as our checklist. So the first part of the set, there are 4 problems, and they're all asking you to do the same thing. They're saying solve this equation and see if they're the same. So basically we're going to simplify both of these equations and decide if they're the same or not. The answer on the formative is a yes or a no question. So the first one is saying 14 minus parentheses 3a plus 2. So the tricky part about this one is that there's a minus in front of the parentheses, which means that I need to subtract 3a from 14, but I also need to subtract 2 from 14. So the trick to this one is that most of you would say, well, yeah, it's 14 minus 3a, but we're going to actually subtract the 2 because we're subtracting this whole parenthesis, that whole section, which means we need to subtract 2. So what we're doing with these arrows that I drew, that's called distributing. And we're basically distributing that minus we're subtracting everything in the parentheses, so the 3a and the 2. So now that we've distributed the parentheses, we got rid of the parentheses, so that's kind of our P. Now we need to combine like terms. So there is a 14 and a 2 that don't have any variables. So the 14, this is called a constant. And this is a negative 2. Notice I circled the negative with it. And that's also a constant. So since they don't have any variables, we can combine them together into one number. So if I have a positive 14 and a negative 2, they combine to equal 12. So then I have 12, and I can just bring down this variable, minus 3a. So that deals with this side. Now we need to look at this side. So is 14 minus 3a minus 2 the same as this one? And actually, that is the same at the second step. So the answer to this one is yes, they are equivalent, which means the same. And if we simplified even further, we would say 14 minus 2 gives us 12 minus 3a. So they are equivalent, they are the same. So that's what you're doing in problems 1 through 4. You're just solving them to their simplest form to see if they are the same, which is what equivalent means. The next one, number 5, is asking you to do the same thing with 4 different expressions. So first you're going to do those grouping symbols. So I guess I want to talk to you about the fraction on number 5. 4t minus 10 divided by 2. And basically you're saying everything on the top needs to be divided by 2. So that means that 4t needs to be divided by 2. And I need to subtract 10 divided by 2. So 4t divided by 2 is 2t minus 10 divided by 2 is 5. So that's how you simplify a fraction bar. You can split them into 2 sections. So you're going to simplify each of these numbers and decide which of them are equivalent and which of them are not equivalent. 6, 7, and 8 all have some form of a fraction, and they want you to simplify and solve for x. So I think I'm going to do number 7 with you. So this one is saying 4 times this fraction and 4 times 2. That's how I distribute. Anytime there's parentheses, whatever's touching the parentheses needs to be done to everything inside the parentheses. So fractions always freak us out a little bit. So I'm going to say anytime I need to multiply fractions, they both need to be a fraction. So I'm going to turn my first number into a fraction and say 4 over 1 times x over 5. That's what I need to multiply together. So, and when you multiply fractions, you just go straight across. 4 times x is 4x. 1 times 5 is 5. So that becomes 4x divided by 5, 4x over 5. And then 4 times 2 is 8. So this is 4x over 5 minus 8 equals 20. So I'm going to write that down a little bit cleaner next to it. 4x divided by 5 minus 8 equals 20. So now that I have my parentheses out of the way, I'm going to go ahead and follow my solving directions or solving equation steps. I'm going to put a line at the equal sign, and I need to get the constants on the same side. So minus 8 is my constant, and I want it to be on the other side where the 20 is. And in order for me to move it, I have to do the opposite of what's already being done. I have to make it 0. So minus 8, the opposite of that is to add 8. And then negative 8 plus 8 equals 0, which is what I want. I want it to cancel out. So I got plus 8 because I'm doing the opposite. And whatever I do to one side, I'm going to do to the other. And that's going to leave me with this side. I'm going to have 4x divided by 5 equals, 28. I'm adding, not subtracting. 28. And then I need to get rid of this fraction. So to do that, I need to multiply by the denominator. So if I multiply this by 5, that's really multiplying by 5 over 1, and that's going to cross cancel my 5's. So I'm going to end up with 4x, and whatever I do to one side, I need to do the other, equals 28 times 5. I'm going to use my calculator for that. 140. So now I'm on the last step. I have my x's on one side, I have my constants on the other, and I need to separate the 4 and the x. And so right now that says 4 times x. And the opposite of multiply is to divide. So I'm going to divide both sides by 4, and I get x equals 35. So that is 7, and you're doing the same things on 6 and 8. And then 9 and 10, you're just substituting in the number they give you. So they say y equals 2. So I need to replace y with the number 2. So 2.5 times 2 minus 10 equals negative 0.5. And then I solve and simplify. 2.5 times 2 is 5. 5 minus 10 equals negative 0.5. And then in my head, I'm like, that doesn't sound like that's making sense, because I know that 5 minus 10 is really negative 5. And negative 5 is not the same as negative 0.5. So does y equal 2? No, it does not, because it does not make my equation true. And those examples should help you to finish the set today.